Well, hi, good morning. Thanks so much for joining me in my shop. Today is April 19th, and I've reached a very interesting point with this radio. I've got a story here, which I've made up to explain what I'm seeing. So I'm just going to go over what I'm seeing, and then I hope to take action without too much more talk and see if we can resolve what the problem is. So this is also done for my sake. Make sure I've got all the ideas kind of lined up and connected together in some sensible way, because things aren't so sensible here. So first off is the observation that with the set operating, pushing the FM button causes the magic eye to disappear. So that suggested to me a loss of B plus in the radio when the FM tuner is engaged. I looked at the schematic, and it's quite clear that when you push the FM button, you close a switch which delivers B plus up into the tuner box here. So logically that would mean there's probably a short somewhere in the tuner box. So a fairly simple matter to trace it down to a particular capacitor which could be responsible for it. That capacitor, you can just see it under the board here, that brown piece. And getting to that capacitor means passing a current through this resistor from the red wire. The red wire comes out to a terminal on the back here, which you can't quite see, and then carries on into the radio. That's got to be the B plus supply coming across in this red wire, fed through this resistor, and then reaching the capacitor, the far side of which is connected to the chassis or to ground. So a short in that capacitor would pull current through this resistor and pull down, assumably, the voltage of the B plus. I measured the resistance of the B plus circuit, took it from this point here on the magic eye, to press the button, and sure enough the resistance went from a very high number, 500,000 ohms or something like that, down to a very low number, 2200 ohms, 2300 ohms. That's another anomaly right there. But that number, 2200, fits with the size of this resistor. So now you would think, okay, B plus here, which is the same as this point, reading 2200 ohms to ground means this capacitor is completely shorted. Job done. Except, now here's all the exceptions, except this resistor, which I'm sure is supposed to be 2200 ohms, isn't. The labeling or the color banding on there suggests it's a 20 ohm resistor. Now, this one right here with the leg up in the air. Red, black, black, and then the last band looks brown to me, but it can't be brown. It must be something like gold. It doesn't look gold. Could I be reading this backwards? Well, either way. If we read it either way, it's red, black, black, or it's brown, black, black. So it's either 2, 0, and nothing more, or it's 1, 0, and nothing more. So it's either a 10 or a 20. It's a relatively high wattage resistor. From the information I could gather from the schematic, the wattage of this resistor would normally be a 0.3 watt resistor, which is a tiny one, similar to all the rest that are in here. So when I put an ohm meter across this 20 or this 10 ohm resistor, I get 990 ohms, 1000 ohms. I get 1000 ohms here. Now, if I read further, let's say from this open end to the chassis, which would be through the resistor and through the capacitor, I should get an infinite, I should get an open circuit indication really, but what I end up with is 2500 ohms. So where's the extra 1500 coming from? If I put the ohm meter right across the capacitor underneath there, I get 1500 ohms. 1500 and 1000 ohms, 2500. So you have a 20 ohm resistor that reads 1000. You've got a capacitor that reads 1500. None of that makes any sense. In fact, what's a 20 ohm or even a 1000 ohm resistor doing here? It should be 2200. So how did all this get to be this way? I noticed the solder connections here. I've redone this one now, but this one is still the way it was. Look freshened up compared to all the rest of the connections in here. So my story would be the receiver stopped working on FM. Somebody opened up this box. They spotted this resistor burned open here, the original resistor, the 2200 resistor burned open. And, well, that must be the problem. For some reason, they did not replace it with a 2200 ohm low wattage resistor. Instead, they put this one in. Now, it's possible that this resistor was a 1000 ohm resistor when they tested it. They took it out of their box, they tested it, they got 1000, they thought, well, 2000, 1000. I'll put this one in. This is a bigger wattage resistor. It'll tolerate the whatever was that burned it out, which is not a very good way to think about it, but that's my guess as to how they did this. In went this resistor. Perhaps it was a 20 ohm resistor. I don't quite understand. I think it's more likely they misread the resistor banding, like I'm having trouble with this resistor, and they may have read it as 2000, maybe. I don't know. So for some reason they stuck this resistor in, the 20 ohm that measures 1000 ohms. They turn the set on. Well, would it have worked at that point? Well, that's an interesting question now, because if it didn't work, then whoever was doing this would continue doing more stuff to the radio, I would think. Or did they just throw their hands up and go, well, I don't know. That's the best I can do with it. Not realizing that the real problem is this shorted or semi-shorted capacitor. Well, that's a weird thing too. There's a lot of weirdness going on here. This isn't as straightforward as I would want. So my options are to accept what the schematic is showing and put in my own 2200 resistor across here. Get rid of this one. Take this capacitor. I think what I want to do is unsolder one side of it, drop it down so it's now disconnected just like the resistor is here. Test it. See what the story is. The thing about this whole box, and I don't know to what degree this is true, but obviously to a fair degree, you can't be moving parts around in here. If you move parts around, it causes rebalancing of the various circuits in terms of their resonance and things like that. So a big coil sitting right here. If I change this capacitor, the one that goes in will have a different lead length, different style of capacitor. This one is a tubular one, dog bone shaped tubular one. I'm going to end up putting in a more classic looking mica capacitor. But is that going to cause some problem? I don't know. I really don't want to find out unless I'm forced to go that way, which I think is pretty much where I am. I'm pretty much at the point where I have to remove this. Are there other components that could develop a short that could be found if measured here at 1500 ohms? That could cause current to flow and burn this guy out. How does a 1500 ohm resistance here cause enough current to burn out the original resistor? That doesn't add up either. There's a number of things not adding up. Perhaps the original resistor wasn't burned right out. Maybe it was overheated and discolored, and that's what prompted this. Perhaps I'm wrong about the whole thing. So, if I am going to go ahead and change this capacitor down here, or take the first step towards doing that, well, there are some other capacitors that are involved in this circuit. There's this adjustable capacitor right here. And there could be another one somewhere, I think. I have to look at the schematic again. It was yesterday since I looked at it. It's possible this thing is shorted out. Have I ever seen that? No, never seen that in a radio. I could turn this and see what effect it has on the resistances in here. then I can put it back to its original location. I can see the slot because the can is off. It's very easy to do now with the can off. Just move it and return it and see what happens. I think maybe I should do that before I take this guy out of here. I should really stop and I'm going to take a peek at the schematic on my own. This is certainly this one, and maybe there's another one in here. Oh, also, there was a capacitor shown on the schematic yesterday. You were probably yelling at your screen as I was talking. And there's a ganged trimmer capacitor with arrows on the end. And all the rest of the capacitors are shown a little bit differently, and I mumbled on about why are they doing that. I forgot. There's that big tuning capacitor inside here, for crying out loud, and that's what was on the schematic that I was looking at yesterday. So if you were all wound out that I was getting things wrong, that's fine. You know, there's lots of things you can get wrong which are totally inconsequential. So as I'm merrily on my way here, I may say stuff and it's really not correct, but it really doesn't matter that it be correct or not. And I'm thinking about this stuff too, you know, I'm trying to apply my limited brain power to where it needs to go. No use firing my missiles off in the wrong place on the radio. I only have so much capacity, like anybody. I can only do this for so long before it's just too much of a jumble. Maybe some people can go for hours on this stuff, but I'm only good for about an hour before I really got to stop, because I'm just going around in circles. I'm starting to get there already, in fact. So, okay, so we're going to hook up an ohmmeter. We're going to rotate this. I'm going to look at the schematic, see if there's some other capacitors that, or things that could be responsible for the short I'm seeing. And then we'll probably go after this capacitor down here, and we'll find out if this is what it's all about. What's it all about? You know, I did a great thing before I came in here this morning. I watched a couple of Kate Bush videos, and now I've got these wonderful Kate Bush songs in the back of my head here while I'm doing work. She's just fantastic. Okay, now I need a little screwdriver. Take notice of the angle on this. Sometimes this reading is not very stable, by the way. Seems pretty good now. So I'm reading through the resistor and through the capacitor to the chassis. I believe that's what's going on, but maybe it's actually going through somewhere else. I forgot to look at the schematic. I got it up on my screen, forgot to look. Okay, looking carefully at the angles here so I can return this. Come on. These are often stuck. There it goes. Okay, let's return it. These are some of these have to be in such a precise location that doing this probably not the best move, but I want to eliminate that as a possible cause of what's going on here. Okay, now I've got to take a look at the schematic, which for some reason I just didn't look at. And here, have a look at it with me. Okay, now just to get myself oriented. So this is the mystery resistor. This is the suspect capacitor. Wait a second. This isn't... Wait a minute. What's happening here? This doesn't look like the same thing I was looking at yesterday. Oh, it is. Oh, because I'm looking in the wrong area. Okay. Okay, I'm with it now. So here's the B plus line coming in. The red wire reaching the mystery resistor here, 2.2K. Yeah, and then this is the capacitor that stands between this area and ground or chassis. This is the guy I think is reading 1500. I think I just adjusted this. So another one here, you could develop a short going through here, a short through the FM tuning capacitor, which is not very likely, or the trimmer I just adjusted. I should tune the radio and see what happens. just in case there's plates in contact. I can't imagine how that would happen. It's all contained and protected from the likes of people like me. So how would it ever happen? And is there any other route? The only other route to the chassis is through another wild, guy, this has to be defective, this has to be defective, this has to be defective. Any way you go up this way, you've got to have multiple failures to find your way to a ground. That's just not going to happen. The tube is not in the socket. The tube cannot be involved in this in any way. Okay, tune the radio. That's really the only other possibility. Only other possibility. It's so unlikely. Okay, I'm going to push the FM button. And tune. No. See, if the plates were rubbing and contacting, that number would be jumping all over the place. Not doing what it's doing. Which is nothing, basically. Yeah. Okay, so next step has to be the removal of one leg of this capacitor under here. Let's take a bit of a closer look at it just so I can decide which leg to take out. We can look top and bottom here. So it looks like it's soldered onto posts or terminals. Gotta get in here a little closer, a little better lighting. This one looks like it's just tacked on the bottom there. This other one is on a terminal. Where's the terminal coming from? Okay, I'm going to change the focus on that camera. If you just bear with me for a moment here, I'm just going to do it on the fly. After all, these are essentially live videos. So there we go. Okay, I should be able to get up pretty close with this now. It just doesn't look like a simple arrangement there. Where's that terminal coming from? Some dirt on my camera lens. The other terminal looks really easy, so let's just do the other terminal. Looks like I just hit that with a soldering iron and it's going to fall off basically. And that would be just perfect if I can do. Oh, what's that coming out of there? Wait a minute, look at this capacitor. There's a white blob of something hanging there at the bottom of that end of the capacitor. It looks broken, doesn't it? That's not quite normal, is it? That ring would be broken like that? Is there a piece of debris down here? Okay. Looks like there's a band. What is that in there? I wonder, what am I talking about? So, oh, there's something else of interest. Or is it? No, it's not of interest. So, okay, never mind. What I'm seeing doesn't matter. But that band that's cascading above the, not really above, but what is this thing back here? It's like a band, a metal band that's been brought out and it's soldered. then what's this on the other side? Another weird looking cone of solder. What the heck is that? Sometimes you just can't figure things out with a camera. You have to look at it with your own eyes, but I don't know what that is. Maybe it's just a lot of solder on a piece of something coming across. So is this capacitor just floating out here on these connections? Let me try moving it here. No, it's pretty solid. So it must be maybe something you can't see in behind where the screwdriver is now. Yeah, it would look like there's a terminal coming from the tuning capacitor, which we can see in the background, coming straight out. So there's a firm terminal coming straight out at the camera, and then a pile of stuff soldered to it, and then this band is a kind of an oddball thing. Can you see it over here somehow? Too much stuff in the way. Just a blob of solder there. So this band is soldered to the inside of this metal piece here. And now what are all those wires? Oh, that's part of a coil right here. None of my business. Okay, so sure looks like the easy thing we can do is pop that capacitor down off that one terminal. It should be able to pop it back. If it turns out there's nothing wrong with it, which I think is quite possible. Don't know about likely, but possible. Okay, let me get set for that. Okay, my soldering iron here, something to pull it down. Wow, the lead is very, very flexible. Hoped. Nothing to it. Okay, now we get to find out what is the story on this thing here. Okay, very good. I think I'm going to bring over an electronic tester. I have found to be very, very reliable. Lead on there. Okay, what can you tell us? "32 picofarads. It's supposed to be 2200 picofarads. But it didn't show the V-loss of 0. Really? This is not quite, this is just added more to this whole mystery here. Nothing is as it should be. It's a resistor, 960 ohms, which matches previous tests. Capacitor again. 32, exactly the same, no loss. 32, no. 32 is a far cry from, it's a far cry from what it should be. So we could make up more to the story here. We could say, okay, so first time around, the resistor that was here burned up, went open, stopped the action. Somebody came in, found that, stuck this resistor in, got the action going again. But this time the resistor didn't fuse. It didn't act as a fuse. It didn't burn out. Just hung in there, and the current continued to flow through this defective component, eventually turning it into a 32 picofarad capacitor. Why did I measure resistance through there? Well, let's measure the resistance of this terminal to the chassis now. You know what? I can do it with this. I think. Can't say I've ever used this meter for kind of a wide-ranging test, but let's give it a try. The capacitor's good. This will say 1500. Where'd the resistance go? There was a 1500 ohm resistance. What? Come on. Come on, it's getting weirder. And you start to think about things like bad solder joint. How could a bad solder joint to a capacitor turn it into a resistor? So I'm going to clip on the ohm meter, the Allen meter. Try to clip it on there. Here we are. Other side of the capacitor. It's almost too bad that things like amps and volts and ohms were renamed after people, because they took away the sensible names. So voltage, before the word volta was common, they talked about pressure, the electrical pressure. And of course for amps they talk about current flow. They don't talk about amps. Those things put certain pictures in your head, which I think are valuable. Volts? That just puts a picture of some old Italian guy in your head. What good is that? Mr. Volta. Okay, so $850 ohms through that capacitor. But at the same time, the other instrument doesn't detect the resistance. Now, if I took that other instrument, took a capacitor, a good capacitor, put a resistor in parallel with it, kind of mimic this, that thing would find it. Or if what it's finding it just doesn't work out, the device will report a defective component. This is really not making a lot of sense. It's really not. But it's suggesting, this last test in particular suggests strongly I should just replace that now. Let's do one more test here. See, I've been down these alleys before. And while you think you're improving things, you're actually not, by accident. And the next thing you know, your situation has gotten much more complicated than you thought, because you've done stuff that have caused new problems. So now I'm reading through that capacitor to the chassis. It's the same resistance. 800 ohms. Pretty stable. Okay, well, the only next step is take the other lead off. Take off the other lead. Let's take a look at the other lead now. I think it's probably not much more difficult, particularly if they haven't wrapped it. Like that, the one I took off, they didn't wrap it around anything. This one could be wrapped. I'm looking for other things that are soldered there that I might accidentally unsolder, because this is a hard spot to see. Looks fine. And you can grab on that resistor and just kind of extract it like a bad tooth. Actually, no, I don't want to use that as a model. When the dentist extracts a bad tooth, there's a lot of yanking and tugging and pulling. That's what I'm trying to avoid here. Yeah, I'm gonna get the. Okay, so a little bit of a problem with the position of the camera. Oh, you can see a little bit written on it now. 2.2 nanofarads, I can read it. Wow, it certainly doesn't read 2.2 nanofarads. Okay, I feel a lot better now. Confirmation of what is on the schematic. I think I'm going to have to just not worry so much about the camera here. If it falls on the floor during this, blocking the light. It's not going well. Yeah, I don't put a lot of the component work on video anymore for these exact reasons. There we are. I made it. I think I made it. There it is. There it is. It's out. It was just tacked in there. Tacked in there, right? Ooh, it's got a black spot on it there. Right up there. Well, I got a black spot on my finger. You know what that is? That's a guitar playing callus. It's from me strumming the strings with the back of that finger. That's my guitar callus. 2.2 nanofarads. Excellent, I guess. Let's test it outside. It's out of the radio now. There's an awful lot of fussing over one little capacitor, but I am carefully avoiding jackpots here. At least I think I am. You know, you want to be in a position where you say, "Oh, I did everything I could." When you're explaining why something is completely ruined. We did everything we could for him, but I'm afraid we lost the patient. Oh, now it wants to call it a resistor. Okay, finally, we have something adding up. Now the value isn't what I thought. I thought it would be 1500 because of earlier measurements, but the value's probably going up and down. Let's try that. Well, I think this thing just takes a reading. It doesn't continue. It just takes one reading and shows it to you. That's enough. We've done enough. We got it. Okay, now 2200. I have to find an appropriate capacitor because I don't have any that look like this, that's for sure. Excellent. I'm going to reward myself with coffee. Coffee reward. Well, I got quite a selection here of capacitors I can use to replace this guy. Any one of these. Which one should it be? Does it even make any difference, really? So these are all rated at 2200, but they all vary a little bit. They're all measuring a touch high, interestingly enough. But not much, just a little bit. I mean, these things aren't that precise. So why would, well, first of all, what kind of voltage is this thing sustaining? It's sustaining the B+. You know, that's 300-400 volts at the most, you know, during the peak. These are all capable of withstanding that. Not quite sure about this one, actually, but I think they're all capable. They're all 600 volt capacitors. Look anything like that, but I mean the look doesn't really matter that much, does it? Or does it? Because this will be interacting with the chassis a little bit. Whereas one side of it is connected to the chassis. We never investigated what was happening with this end of this thing too. And we'll do that in a moment. Well, it's kind of an eeny, meeny, miny, mo. I got lots of all of them. You can see my little bucket over here. Another alternative is to take a couple of these. I'd have to use two of them in parallel. That's not a good option at all. Not when I've got these. These three are all flat guys. And this one's a rolled up one. Exactly how these are done, I don't actually know. I'm going to guess there's an inside and an outside and an insulator in between. And the capacitance is controlled by the dimensions. Capacitance is controlled by dimensions, isn't it? Okay. It's kind of a random thing. I think I'll use this guy. This one's the closest to 2200. I'll put this guy in. Very good. Good choice. Good choice. Well, in the camera it doesn't look great. It looks better with my eyes. Now the other side of it. Well, it's soldered in really good on the other side. Some excess wire up at the top. I don't think would matter much. Yeah, maybe a little more solder on that. What about it? What am I going to do about this resistor? Start thinking about that. Well, I should go with the schematic. That's what I should do, I think. Can't really get more solder onto it than that. Okay, capacitor done. Resistor time. For sure, it should be a 2200. $1,000. Inexplicable. Why it's 1,000? Well, what would 1,000 be? 1,000 would be brown, black, red. Brown, black, red would be 1,000. I've seen a million of them. Well, out it comes and in goes a 2200. That's what we got to do there. Okay, so I've tested the one I'm going to put in. Whoa! Let's test it again. $21.95. There's that little guy there. That should do the trick. Okay. I'm going to put that in. So easy. Very large terminals here. Why so large terminals? It's almost as if they anticipated something happening here. There are some very fine wires right in this area. There's a very fine wire right up coming off this coil. Easily break it and never even see you did it. Another reason why I don't like working in these areas. There we go. Okay, yeah, break a wire lead on a coil, and might as well just start the headache. There we go. Okay, you know what it's time for? Almost time to try this radio again. A couple things though. Drop the box back on it, gotta hook these wires back up, and I think I've got to test and replace the tube that was in here. Because the tube that was in there was bad. Okay, that's good. Very close to getting it working, I think. Why don't we take a moment to have a close look at this capacitor, and what is there about it that might make us think it went kablooey somehow. So there's a drip of what looks like solder here, and that's probably what it is. Could it have come from inside there? It's probably, the whole thing is a soldering iron strike. Probably this piece that's missing right on the end here has probably been taken off with a soldering iron. I don't know. Didn't I see a little hole in it? Thought I did. I don't see anything. Mysterious. Okay, might have to look at that resistor, although I don't think there's anything much to see here. See, like that's got brown, there's definitely brown on one end, red on the other. Of course, when you heat these things up, some of these colors will change a bit. Like the two black ones, they don't look exactly the same. And there's no real evidence of heating, although it does look a little darkened in the middle, just a little in the middle. No obvious signs of deterioration. I wish I could say that about myself, but I can't. So, okay, carry on here and get things ready for a test of the FM. Okay, now for a little bit of tube testing. So this is already set up for an ECC 85. That's the tube that was in the radio as an FM, the FM position, ECC 85. So my expectation is this is going to show up weak or even as a failure based on earlier testing and what I remember of it. Okay, put that in. Then if we can't get along with this tube, I don't have any more like that, or 6AQ8, it's the same tube, but instead I have a whole bunch of these 6BQ7, 6BZ7 tubes, which in another similar radio proved to be satisfactory for use. Okay, first we check for shorts. Oh, okay. Well, now this is interesting. So we're seeing the meter come up a little bit on this short test number 5. Don't think I'm going to pursue this, but we could figure out what kind of short it is that's in here, and whether the short in this tube is what started the whole ball rolling. I don't know. We're not going to bother, because I'm bound to replace it anyway. So we're going to switch right away to a 6BQ7. I'm going to leave it set here for a 6AQ8 or ECC 85 for the original tube. The settings for this are probably slightly different. Take a look while it's warming up. 6BQ7 won't be too far down the way here. 6BQ7. So it would be 17L on the bias. The bias here is 21L, so the bias is a little different. BGK76. Oh, that's entirely different. 351. That's entirely different. That's not supposed to happen. About 6BZ7. Basically the same tube, 6BZ. EGK76 3510, same as the other one. Oh, I already got it plugged in. Well, I blindly did this already. Should be like that. Blindly did this already with these tubes. Test the BZ or BQ7 as if it's a. I can't even finish my sentences. Yeah. Well, you've come in at the right time, Peanut. Okay. Well, let's just see if we can find a short in here. I would stop it now. Yes, sir. Here we go. Look at that. So it reads 1,000. So it reads just under 1,000, and the magic number, if that was an ECC, a 6AQ8 or an ECC 85, would be 1250. So that's really just a little low. 1250 being the reject point. So the tube tester results are suggesting this tube is too weak to go in the radio. I don't know what to think, man. My head is just spinning because the settings should be completely different. And some of these tube testers, I have another one that actually says plate, screen, right across the top. This one doesn't identify what each of these controls is. So maybe it's a combination thing that in combination these controls do connect to certain pins, but maybe they're not direct. I don't know. Although I think you would think they would label them if they were the case, if that were the case. So if this was always the I don't know, the grid connection, then this would say grid up here. I don't know, that's a mystery. Let's get another tube. Keep going. Peanut, you just have to wait a couple minutes, okay? I'm just going to be preoccupied here. This one says 6BQ7, 6BZ7 right on it. Now, I got the idea of utilizing these tubes by reading on the internet discussions about doing this. And it was up and down. Maybe what the key is, you need a strong one of these to replace the original one. For shorts, showing up, the shot. This is about better. This is right at the reject point. Reject point is a little generous. This one's a little low then. So this is a possible one. Yes, Peanut. You can't go out today. It's terrible outside. So this is a maybe. I'll put it over here in the maybe area. I have too many of these tubes to test all on video here. Here's another one, 6BK7. Somewhere I have I kept these tubes in order and I have a piece of paper with the test results written on it. I have to do this. Oh, you're giving me a look. You're really giving me a look, Peanut. Okay, we'll test this way. It's a two-part tube, so we flip these switches to test the two different parts. This is one part. That's a good one. Test the other part. That's the good one. Ooh, what's it doing there? Yeah, it gets better if you just kind of give it a little push. This would be good enough to put in the radio. There's no short in it. There's nothing like that. There he is. What do you hear? Go see. Go see what that is. There, go. Quick. He's not looking. Quickly. He's not looking. I'm going to stick this in here. I think I'm probably going to operate this with the can off first. The first test being, is there still a short? Does this resistor get hot? I think the first time I operate it will be with the can off. So it may not tune well. I know you don't have to, well, I will, because we want to hear it. I'd like to hear what happens. Peanut, I'm coming now. Okay? I'm coming now. Okay, just about ready to go here. Now, you can see the resistor up in the top right-hand corner of the camera. And I also have a thermal viewer here that I plan on using. I just need to make some settings here. So this will show anything that's getting, say, around 30, 40 degrees centigrade. They'll start turning red on this viewer. 30. That should do it. So, can you see my hand? It's not red. Shouldn't I be red? Aren't I 35? Maybe I'm not quite 35. Of course, there's nothing in here that's warm now. This is a chance to check a few things out. This is very hard to see on the camera when I'm using it, but I have it ready so I can really actually measure the temperature of this resistor, which I do not expect to warm up at all, really. Radio's already set on broadcast. We want to watch for the magic eye to come on. It tells us the B plus is intact. We need to plug it in. Need to just get this off my bench too. Okay, I think we're ready. Let's hit the power. This will come on right away. In fact, we should keep an eye on the dim bulbs. There they go. And back down. As long as they go down, we're golden here. Let's put on the full power. Any smoke yet from the resistor? How did it get so dark? Of course, there should be nothing going on with this resistor until I push the FM button. That's the moment where all the action happens. Okay, you can see the eye coming on. There's the radio playing. Is everything ready? Just waiting to see if there's any heat visible. I know there's some heat over here already, so this is again very hard to show you in the camera, but you can see that red blotch, and that's looking right at the output tube, right in the back here. And you know, you can see the heater with your eyes. That thing can see the heater too. This is the test. So the main thing is to watch what happens to this eye when I push this button. Here we go, and it stayed on. Excellent. Quickly back to watching the resistor now. I don't think there's any reason to be concerned. I will make an observation of it. It's also tricky to tell what you're looking at in this camera here. I'll give you a chance. Okay, so we see a red thing here. That's the tube. Okay, and we see a red thing over here. That's the camera. And in between, we see a little spot. We see a spot getting hot. That's got to be that resistor. How hot is it getting? So if I move this until the red spot is dead center, can you see the little plus mark? Then this number down here will tell, I'll put it this way, this number tells you the temperature of the plus mark. So we will aim this until we get great light. Come on. There's another way of doing this. There we are. 40 degrees. Whoops. Why am I having such a hard time? I swear it's moving on its own. There we are. It's a wide angle camera. 40, 62, 65. That's getting warm. It's getting a little warmer than I thought it would. Anything happening to it on camera? No. Should I touch that? It's definitely warmer than I would want. I think I saw 70 go by just now. So another way is, it's hard to see, but there's some small red and green writing here. The red writing is, see, there could be something else wrong here that's causing this whole thing to happen. And if I really got that resistor, 57, 55, it is tricky. 70, those are the numbers I'm seeing with this. 70 is a little warm. It's really tricky. 80, 85. That's pretty warm. Any smoke coming out of it yet? I don't think so. That is pretty hot. I should have put up maybe a bigger wattage in there. I mean, it is taking the plate current from the tube here. Do I touch that? That's a little warm to touch. Warm to put the finger on. Hey, what is this working? Are we gonna hear any FM? I stuck an antenna on it. Wow, it can't get any quieter than that, can it? Gosh, that's really quiet. Oh, dirty button, dirty switch. Well, we're in business. I gotta think about changing that with a higher wattage resistor though, because I'm really quite worried. That guy's just not gonna last. Now that kind of resistor can take quite a heat. It can probably go up to 90 degrees C. It's probably still within its safety range. I don't know offhand. Most electronic things can run up around 90 C. 90 C is burn your finger quickly temperature. Well, I'm so tempted to touch it. I can hold my finger near it. So I find the back of my finger, despite the thing there, very sensitive to heat. Back here, right in here. Another really good spot. I can feel the heat coming off the. You can see what I'm doing. I can feel the heat coming off this tube. This is a small source down here. My personal human infrared sensor says, yeah, that thing's pretty hot. Let's keep it going. We're giving it 115 volts, so you could get a little more from the outlet and get a little hotter. Yet, let's check it again, because it's probably reached its stable temperature here. This is a great thing. Everybody needs one of these just to have around the house. I found this to be very, very accurate. Now there's such a large red blotch here. Okay, so what I've got to do is I got the red set for 35. Let's move it up. Move it up. 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 40. 50. So we want to set just really the top temperature that it gets to, about 60. So this is adjusting the color range on the screen. Okay, once again I can see the resistor itself. You can kind of see it on an angle there a little bit. Now I'm going to center this up. So we're getting like we're getting 85, right at the top. I think I got to put a higher wattage resistor in there. I think that's what I need to do. Even if that guy can tolerate it, it's just a little too hot, I think. So a higher wattage resistor still dissipates the same heat energy, but because of the larger body size. And you know what? This also answers why there's large terminals here. The objective is to isolate the very hot resistor from everything else. So I think if I put a larger wattage resistor in there, it won't rise to as high a temperature. And if I position it a little higher, a little more like the last one was, we should be good. Plus a resistor running hot like that is it's going to have a shortened life. Okay, that's what I'm going to do. I'm going to change that. I have options here for resistors. So I've got 4 here. I think I'm going to be using this one. This one would probably work pretty good too. It looks like a high quality, higher wattage resistor, certainly than the one that's in there. Maybe this is the one to go in. This one's a little bit overkill, I think, for that duty. Let's check the resistance on these, just to be sure. $2,230. Comes with a few extra ohms. You can't beat that. This one is, I'm not even going to measure it. I did already. 2.2K. But this is a wire wound resistor. I'm pretty sure there's a wire winding under here. And it's essentially a coil. And no. This one is a vintage, never been used resistor. The leads here are a little rusty, but let's just see what this one comes out to. So in my mind, resistors go high as they get older. 2200, but in fact it's 2560. It's gone up a little bit, and you start using these old vintage ones, they might drift off, and now I might as well complete the set here. Let's see how accurate this one is. Not that I'm going to use it, because it's too much. What do you say? Supposed to be 22, it's 2350. So that variation probably wouldn't matter in that position. It would cause a little bit of a difference of plate voltage on the FM tube. I don't think it would be enough to worry about. This is the winner. He's going in. Very good. Cut the other one out and put this one in. And I think if I had just given this a little more thought, I raised the question, well, why the big terminals here? Well, because they know the resistor is going to get hot. So they put these big terminals here. And you notice the last resistor, the one that someone else installed, was installed like this one, with a long length here. And that's to help prevent the heat from drawing down into these connections. So it kind of stays in the resistor, if you like. Another approach, like the last resistor I put it in very, very close to the terminals with short leads. In that case, the heat will travel down the wires and get into these connections, and that'll draw the heat off. But I think we saw in the end there was too much heat. So I've taken this approach. Now we're going to heat this one up and see what happens to it. Okay, the way I've got this arranged now, I've got my thermal viewer sitting here. I've got the other camera sitting there looking at the thermal viewer, and the thermal viewer is looking at the resistor and any other parts that are within view. The thermal viewer is a wide-angle camera, so it covers more than you might imagine. So if we look through that camera, we don't see much there. I'm going to bring over my hot soldering iron. Hey, this is interesting. How hot is the hot soldering iron? Well, you can definitely see it there. Now, if you look, you'll see on the screen here, you see this large number here. Whoops, move this. 25.9 in that. That's telling you the temperature of the plus sign in the center of the screen. And you can see a max and a min. And the max in red, I think it says, looks like 26. It's a pretty uniform temperature there. When I bring down the soldering iron and try to stick it under the plus, and we'll find out what my tip temperature is. It'll be over here. Here we are. Come on. There. 123C. Jumping all over the place. Now there are problems with using these infrared guys. Let's put it down here better. There we are. Now we're getting something better. 220C. And I've got it set, according to the soldering iron, 350C. Wow. I've never tested, never looked at anything this hot with this viewer. Maybe it's out of its range. I'm not showing anywhere near it. But in normal use, I found this through comparison to be very accurate. It agrees with all kinds of other thermometers and stuff like that. So we're going to believe it. We're going to believe it. Besides, it's not necessarily a really quantitative test. Qualitative is kind of what we're after. Here we go. Okay, we're all set. The set's going to be switched on to broadcast to start. There we go. Okay, tubes are warming up. Let's just watch the camera now. We'll watch the other camera because that's where the excitement will be. We shouldn't see anything because the FM side's not on. But if I swing this over, you can see that red spot there. That's the bottom of the vacuum tube. Remember, everything's on its side. That's the bottom of the vacuum tube. So, you know, yeah. I was going to help understand the image, but confused myself. Hold on, camera. Don't fall over now. Everybody stay put. Everything's just kind of jury-rigged here. Okay, so we do not see anything from the resistor whatsoever. Now we're going to switch to FM. That was AM. This is FM. And we will see if we see some heat build up there. Okay, I see something getting warm. I think the camera's aimed a little off. I'm going to move it this way. So the thing in the corner is the vacuum tube. And the yellow spot that's developing is the resistor. If I want to know the temperature of the yellow spot, I've got to get it under the plus, because the tube is going to be the hottest thing. Okay, this is... I find it very hard to steer this guy around. There we go. 54. It's turning a little red right in the middle there. Like 60, whereas before we were getting 90. It has a certain thermal capacity. It's a larger resistor. So it has a thermal capacity. It takes time for the heat energy to drive up its temperature. As soon as the current is flowing through it, the heat is being produced. Heat and temperature being two different things. Okay, so now it's looking a little redder. 70s, it's still getting pretty warm. But obviously that's to be expected. And I put too small a resistor in there to start with. Let's get right in the middle of it here. Looks like 85, might be 85. It's still getting up pretty warm. And how's the radio sound? So I imagine, oh, I got my hand on it. I was going to say, is that my imagination? Did the volume change? I got my left hand on the volume control, and that's what did that. Let's see if we get some talk. Talk should be right around here.
It's going to be doing a lot. Might not give you a lot of shade right away, but it's going to eat a lot of carbon dioxide from the top and give you back some oxygen.
We're going to want to go to the calls, but I wanted to ask you Earth Day in general. How does the gardener contribute? What is their contribution?
Well, planting is one thing. Composting is huge. It is huge because it gets us down to that zero footprint. You know, you do the planting. When the planting's done, what you don't eat, what you don't consume, and it may be just a visual consumption, you take it and compost it, let it break down, encourage the fungus in there, and put that back into the soil that you've been depleting by growing, so we continue the cycle, we complete the loop, and that is huge.
Well, I don't know. Here in Canada, we live in a country that parts of it are just covered by huge boreal forests, huge, that make anything we're doing as people in this respect look pretty small and minor. Well, it's gotten much hotter than I would have expected. 104 now. Okay, let's take a look at it and see if it's discoloring or something. I guess we can look at it right side up now. Well, that's one hot sucker there. Boy, you wouldn't want to touch that guy. And I don't think it said anything about the wattage of this resistor in the parts list. So I'm going to let this run for a little while and see if that discolors, because 100 degrees is hotter than I expected, that's for sure.
Coming back. When I moved out
Okay, so here's the resistor list. This is for another radio, but I think it's for exactly the same. All wattages half watt or less, unless otherwise specified. So there it is right there, R6 2200, nothing specified. You can see if it's a higher wattage one, they write it right there. Half watt or less. So they don't expect this to get this hot. Is there something more going on with this radio that's cooking that? And what, all that scratching, that's a cat. Hello? Who's there? It's you. Well, come on in. All the way. Come halfway. Cats have this thing where they like to come halfway in. For some reason, they like doorways. I think they like sniffing the doorway because they know that's a pinch point for, you know, any animals that are wandering around. Go through the doorway. How about another look at that resistor? And there it is. It's not discoloring or anything, but it must be darn hot. Now let me just look at it myself. Here. Okay, putting the viewer on it. Well, this thing will go as high as 113 C. Boy, oh boy, oh boy, oh boy, oh boy, that's hot. Is there something more going on here? We'd have to do a calculation. We'd have to do a calculation of plate current and the resistance there. So I took a look in the two manuals I have for the plate current that should be flowing in that FM tube. And for the proper tube, the 6AQ8, and also for the one I'm using, 10 milliamps. And that's kind of typical of that kind of small signal tube, 10 milliamps. So I found this page quickly on the internet. I've typed in the resistance, 2200 ohms. I've typed in the current, 0.01 amps, that'd be 10 milliamps. This voltage it calculated, and this wattage it calculated. I did it on here because the first time I did this, I just did it in my head. I got 20 watts. No, not 20 watts. 0.2 watts. A fifth of a watt. A fifth of a watt. Well, so I think ultimately success, but wait a minute. Maybe not. There's no way a fifth of a watt would heat up that resistor the way it's heating it up. It just can't be the case. Something more must be going on in here. So tomorrow I'm going to have to carry on working with the question of what is going wrong in this circuit. Why is that resistor getting so hot? And what's up? That's the question. So thanks a lot for watching to here, and 3 days on one little fault. Tomorrow I'll solve it. That's why it's going to be 3 days. Thanks a lot for watching. See you tomorrow.